Hello and welcome to the lecture on ARP and RARP. ARP stands for Address Resolution Protocol and RARP stands for Reverse Address Resolution Protocol. But before we go into the concepts of ARP and RARP, we must understand the concepts of broadcasting. At the IP layer, we have seen that there are two types of broadcast addresses. One is direct broadcast address, another is limited broadcast address. So, what is limited broadcast address? At the IP network layer, it is 255.255.255.255 and at the MAC address, at the MAC layer or we can say it is at the data link layer, we are having an address of all ones, which is 6 bytes of all ones, that is FF colon FF colon FF colon FF colon FF colon FF. This is MAC address. So, this is again one type of broadcast address which is there, right. So, along with this we are having the concept known as directed broadcast, right. So, if the network is let us say 11.0.0.0 and I told you that one more address is there, that is 11.255.255.255. So, how does all of this works together? So, broadcasting if you see broadcasting with IP addresses, that means that the network layer that means at the network layer, broadcasting with IP addresses means that it is at the network layer, and broadcasting at the MAC address means that it is at the data link layer. So, how are all these broadcasting addresses working together and how is the concept of broadcasting implemented? So, that is what I wanted to explain you now. So, let us say there are these layers which are there. So, application layer, transport layer, network layer, data link layer, physical layer and so on. So, let us say there is a machine A on the network and wants to communicate on the other side. Let us say then in that case what is going to happen is the message, whatever is there, this message at the application layer will be given to the transport layer, and transport layer will be adding the port numbers to it. So, let us say the X and Y are the port numbers at the transport layer which are added. Then at the network layer, this message with the port numbers will be added with the source IP and the destination IP. So, if you see your source IP is the IP address of the A machine and the destination IP is the all ones, right. There is nothing but 255.255, which is limited broadcast address. So, destination IP is 255.255. Now, again when we submit this to the frame at the data link layer, we then have the MAC address, right. So, MAC address of A, that is nothing but the Ethernet address of A, we know that, and we do not know what is something. If you want to communicate to the all the machines on the network, then what we do is we put up the destination MAC address as all ones. So, complete 6 bytes will be set to all ones, and then it is passed to the physical layer. So, when we see this it is passed to the physical layer, and physical layer will be making sure that the frame is available to all the machines in the network, and also we must see make sure that it is always the router is going to work at the network layer, and hence it is going to be bounded, right. So, this means what, that your packet, your limited broadcast address or any of the broadcast address packets will always be dropped by the router. So, packets will never escape the network boundary, and router will see that it is a broadcasting packet, accept it, and but will never forward it. So, what it will do is it will simply discard it, right. So, this concept is a generalized concept and could be applied to any type of line. So, let A wants to send the packet to all the stations in the same network. So, this concept is known as limited broadcasting, and to differentiate between networks, when we are sending it to the different network, then we can say it is a directed broadcast address, right. So, there is no broadcasting done at the network layer. Even if it is done with the support of the broadcasting at data link layer. So, there is no real implementation of broadcasting at the network layer. Think about how directed broadcast is implemented, right. And internet does not have the concept of broadcasting, only LANs have the concept of broadcasting. So, then we are interested to see what is the next protocol, using this as the base for the various types of addresses that we know now. limited broadcast address, direct broadcast address, and the broadcasting at the Ethernet layer, the data link layer with all 6 bytes are set to 1. So, once these concepts are known, then we can discuss what is the address resolution protocol. So, in this address resolution protocol, so you are having an IP address, and the we are interested to find the MAC address, right. So, IP address is known, but the MAC address is not known. So, if you do not know the MAC address of a station, then and if you know only the IP address, then you are going to use this ARP in order to get the MAC address. That is the meaning of this. And what is going to happen is, it is going to make use of the higher layers, and it will get the data from the transport layer. Then it will be that data would be available, that packet would be available, or the segment would be available to the network layer, and IP will take that information and then pass it to the address resolution protocol. So, before I go into this, let me tell you what is the actual situation here. So, see here, the IP protocol is above ARP and RARP, and ICMP, IGMP is above the IP, right. So, but however, all of these protocols are at the network layer. So, your IP information will be submitted to the ARP protocol, and then this ARP will be passing the information to the data link layer, right. Now, if there is a network and if we want to pass the information, so then what are the various things that could be done, right. So, let us say this is a network, and each of this would be having the IP address, but the MAC address is not known, let us say, for some of the machine. In that case, let us say system A wants to communicate to some system B, and system B is then having, maybe after that the system B, there is a router. So, what will be the situation that will be happening is that in that case, let us say this is the situation, A and B are in the same network, and there is a router which is blocking, which is differentiating this small network. And what will happen here is, the IA and IB, these are the IP addresses which are there for the two machines, right. So, the request packet would be generated, let us say, see here, request packet would be generated by the ARP, and this ARP request packet would be then submitted to the IP, right. And what it will then happen is, so again see, IP is sending the information to ARP, but then ARP, after that request packet is generated, again it is submitted to the IP, right, and then it is submitted to data link layer. So, in that way it is going to happen. So, IB, then MAC address of B is not known, right. So, we are interested to find what is the MAC address of B. So, and we know what is MAC address of A. So, then what we do is we broadcast that packet to the entire network with all ones, right, 6 bytes 1. So, this is how ARP request packet would be generated, and once this requesting, so ARP will always ARP request will always be a broadcast, but what will happen is, B could be either in the same network, or B even could be there on the other network. So, there are two possibilities which could be there, right. So, how will you find out? Then in that case, what you have to do is, you have to use the network mask, that we have already discussed how to use the network mask and identify whether this machine belongs to which network, right. So, now what we know is the MAC address of A and MAC address of B, and the ARP reply packet will be having the IP address of B and the MAC address of B, right. So, that is MAC address of B, which we were interested with to find out, is extracted, and then we are replying it back to the to this machine A. So, ARP reply is always going to be a unicast. So, what we can see is, in order to understand a message, it is going to come from network layer to data link layer, and all of this and all of this, and we are going to take this network layer datagram, and we are going to put it in the frame, data link layer frame, and that data link layer frame we are going to put the destination MAC address of the destination itself, if it is present in the same network, right. So, if it is not present in the same network, then we are going to put the MAC address of the router, right. So, now considering this as the situation, then there are various possibilities which could exist, that ARP is applied for various cases, like ARP request is one is ARP request is broadcasting, then ARP reply is unicasting, and there are 4 possibilities which exist, which are host wants to find out the MAC address of another host, so host to host, and second case may be like when a host wants to find out the MAC address of the router, so host to router. Then the third case may be a router wants to find out the MAC address of another router, so router to router, as well as a router wants to find out the MAC address of the host, so router to host. So in this way, all the possibilities which exist are supposed to be taken care of, right? Okay, so now this is the situation, like now, I mean, this is the ARP packet which is going to be there. So there are 2 operations. One is the request with number 1 and reply with number 2. In this way, there is an ARP packet which is going to be there. You may look at this presentation slides. I am going to share this presentation slides with you, and maybe you can it's all the theoretical stuff which is there. So I was talking of these 4 cases. So here are the 4 cases. So host to host, then host to router, then router to router, and then router to host. So in this way, things are supposed to be there. These 4 cases could be possible with the ARP, right? And an ARP request is broadcast and ARP reply is always going to be unicast. So there are few examples which I am putting up in front of you, that you can scroll through it, and there are examples which are there to solve for you, right? And this is the ARP full component. However, we are not interested to see all these components in detail, but yes, ARP request, ARP reply, these 2 things are of interest to us, right? And it is always going to be working in sync with the IP protocol, right? So this you can scroll through and understand it. Okay, so next is RARP. So RARP stands for reverse address resolution protocol, right? So it is like in the earlier case we have seen MAC to IP, IP to MAC is ARP, and the reverse of that is that means we are having a MAC address and we need to now have the IP address, then we call it as which protocol we will use is reverse address resolution protocol. So given the MAC address, and if you want to get its IP, we use RARP. Let's see what is the use where it is useful. Many of the hosts do not have the hard disk, right? So many of the hosts do not have the hard disk, and so all the files are going to be stored on the central file server, maybe we can call it as NFS, and so you actually sit on any computer and still you are able to access your files from any of these machines, right? So nothing is stored on your any of the client, and therefore there is no need of any hard disk. So now without hard disk, the computer cannot remember anything for a long time, or whenever you turn it off and turn it on again, so everything will be vanished, right? So every machine will have a ROM memory. So when we say there is a ROM memory, that means whatever is present on the ROM machine will be remembered. So MAC address is present in the ROM of NIC, so it is going to be permanent. But if you look at the IP address will not be present at the ROM, it will be present in the RAM. It is a software number, understand, it is a software number and not permanent. And whenever you turn off your computer, there is nowhere that your computer can save your IP address, right? So therefore the IP address is in RAM and will be lost. So other situation is, let's say all the machines are having hard disk, and a new machine is connected to the network, and it does not know what its IP address is. So whatever the case, the computer does not know its own IP address, but it knows its MAC address. Then how does a host gets its IP address? So if it is if it only knows its MAC address, then what will be the situation is it will have to generate it will use the RARP protocol, and RARP does not take support from IP, neither IP takes support from RARP. Actually IP takes support from ARP. So the only purpose of RARP is to fetch the IP address for the computer, and configure it. So, how does this RARP works is, so if A does not know whom to ask, then there will be a central server called as RARP server. The main purpose of this server is to remember what is the IP address given to what MAC, right. There will be a requirement of mapping table which I have shown here. There would be mapping table which will be there with the RARP server. So, there will be what will be there inside the mapping table. So, there will be MAC address and the IP address. So, for this MAC address, let us say M1, there is IP address I1, for M2 there is I2, MA there is IA, and so on. So, everything will be stored in this way inside the table, and what will be required to be done is, there will be something like RARP request which will be generated. So, at the network layer, you know the MAC address, you do not know the IP address. So, I told you earlier that 0.0.0.0 means what, I do not know my IP, right. So, it will set this as the IP address in the RARP request, and it knows the MAC address of that. So, that will be used. So, that will be submitted to the data link layer with the above information. It knows the MAC address of A, and to whom it will send it to all the machines. So machine A will will do the broadcast to all the machines in the network, and it will be blocked by the router, and router will not forward it. So, internally, if the RARP server is there, who is going to address this issue is, all will receive it, but only RARP server will reply to this particular request, right. It will identify, okay, which is the protocol and who has made the request, and based upon that it will look into the mapping table, and it is supposed to reply to that particular MAC address with the IP, right. So, therefore, at the network layer, a RARP request packet will be produced. In this packet there will be many things, but the most important thing is what is the MAC address and what will be its IP. So, 0.0.0.0 means I do not know my IP address. If anyone in this network knows about it, please tell me, right. So, which means this packet will be given to data link layer. Now, this data link layer has to take this packet, and it has to put it in the frame. So, source MAC address is MA, but now the destination MAC address should be MAC address of the RARP server. So, we do not know it. So, if we do not know whom to ask, the concept is, what we should do is we should broadcast it. Therefore, a data link layer destination MAC address would be all ones, 6 bytes of all one, that is FF, right. So, only RARP server will reply, and RARP server will search in its table. What it will do is, it will search in its table and it is going to reply to it. So, which means RARP reply will say, what? To machine A, the MAC address which was there, which is already known to it, MA, right. MAC address of RARP server is MR, and the required IP from the IP table will be extracted for the MA, right. So, understand, RARP is working at the network layer and not at the application layer. So, even if I am calling RARP server, it is not it need not be at the application layer. It is simply a device which will take all the broadcasting packets and analyze it, and in case if it is having a request packet, then in the table it is going to see it and send it. There is nothing called a concept of server or anything. It is just running at the network layer, right. So, RARP is understand, RARP is used long back in 1980s. Right now no one is using it, and also whenever we do broadcasting at the network layer, it will never cross the boundaries of the router. These things you should remember, and that means that if the RARP server is in the same network, it will get the reply. In case if the RARP server is not in the same network, you will not get any reply, right. So, what is the situation is, if the machine is there on the other network. So, in that case, let us say there are 4 networks connected. So, in this case, if you have more than one network, there is no way the station in other networks will communicate with RARP server. The reason is, even if RARP request is broadcasted, that will be discarded by the router. It will never be forwarded. So, the main disadvantage from this is what we can extract is that the in RARP is, if there are 4 networks, and in every network I need to have RARP server, and every RARP server will have mapping tables, and it is not, therefore what will happen is it is not managed at the central level, but it is at the distributed level, and whenever it is distributed, no, there are going to be various errors related to the updations. So, by mistake you may assign also, no, there could be a possibility that by mistake you may assign one IP address to one network, and the same IP address you are giving to one machine on the another network. So, then what will happen is the two stations are going to get the same IP address. So, that will result into an IP address conflict, right. So, that is an issue. So, another disadvantage of RARP server is the mapping table would be static. A MAC address is assigned right, no, a MAC address is assigned to IP address forever, and if I have 100 stations, I should have 100 IP addresses, even if there are they are using them or not, right. So, even if they are using them or not, still 100 IP addresses are supposed to be given. Okay. So, let us consider a scenario. In your office there are 100 computers, but at any time 50 people work in a day shift and 50 people are working in the night shift. So, but still according to the RARP it states that, no, that even though only 50 people are going to be online at any time, every station should be given an IP address statically. So, IP address number of IP addresses should be greater than equal to the number of hosts which is there. So, as of now this entire system is obsolete, and what is currently in use is bootp and DHCP. So, what we will do is we will break this video here, and I will give you the bootp and DHCP in the another video.